In this video, we're going to show you how to validate your Z-axis platform calibration. We do not recommend to calibrate on a regular basis, but we recommend to validate or check your zero position on a regular basis. It can be necessary to validate it under certain circumstances directly after a print. That is when you had any kind of print failure which you cannot attribute to your print preparation in software. For example, you receive the message of traversed layers, you receive the error message of approach fail or obstruction detected. One possible mistake could be a misaligned platform. Also, when your objects are not sticking to the platform, this is usually a sign that the gap between glass and platform at zero position is too large, so your platform is not at its correct zero position and might have shifted. Even if you don't have these errors, we recommend that you validate your zero position on a regular basis. Depending on how heavy duty your machine is operated, we suggest to do this either every day before you start printing, or every second day, every week, or every 5 prints. Depends on your heavy duty. So how do you calibrate? How do you validate your zero position? Make sure, first of all, that the glass is perfectly clean and the platform is perfectly clean. You don't want to have any resin or any other liquid substance on here, and you don't want to have any particles on here or here. Especially not any hard particles which could scratch the surface. Now, once you've made sure everything is clean and your platform is inserted, what you do is you go to Maintenance, Encode, Position Encoders. You zero the position encoders. They can drift, so that's why we zero the encoders when it's above the glass. This can be at home position or at 1 millimeter, for example. Now you move the platform all the way down. And in this case, you can see that the total is 2.58 and the dot moved up to here. This means that the platform is actually touching, or let's say pushing, on the glass in the back. That's why the dot has shifted to the back. This is usually because the platform has tilted due to any reason. Maybe miscalibration, maybe misalignment during an obstruction, like a particle which exerted severe force on the platform during a print. You can check with your paper. You see that you cannot fit the paper in. The platform is now really tight and pushing on the glass. So this is a typical case where you would recalibrate your platform. I've now recalibrated the platform in the meanwhile and returned to the zero position encoder screen, moved the platform already a little bit down. You see we have a total weight of 0.00 fluctuating around 0. That's completely fine, the dot is not moving. We now move down to 0 again, and you see there was a slight increase. But now it's stable again. The slight increase is from it's actually a good sign. It's from the air being pushed out of the gap. Now the dot is stable in the center. We don't have any result on any of the encoders. That means the glass is now, the platform is not pushing on the glass. We now test with the paper whether there's a large gap, because if there was a large gap, the test would also be valid, because would also be positive, because we wouldn't have any contact to the glass because of the large distance. Now with the paper we can check whether this is the case, but as you can see I cannot fit the paper below any of the corners. This means we have the perfect conditions, which are your platform is not touching the glass at 0, while the gap is not larger than 100 micron. The 100 micron gap, or a gap smaller than 100 micron, has shown to be a successful criteria for, or a criteria for successful adhesion of, let's say, 99% of the materials you will encounter during your printing. If your gap is larger, let's say you can fit a paper in, that doesn't mean that you will have an unsuccessful print, but some materials might adhere worse to the platform than others. That depends on their reactivity and their chemical formulation. And those materials which adhere harder or which adhere less to the platform, they might then fail to adhere at a certain spot. Imagine your corner here is higher or is above the glass, and you can fit a paper in, or maybe two. That might lead to the objects printed at this corner not adhering to the base, and then having an unsuccessful print of those objects, while the rest of the objects might print. If all of your corners are lifted far up, you might have nothing at the platform at all, and the rest would be inside the tray, so you would have to clean the tray afterwards. By ensuring that you don't have any weight on the encoders and that your piece of paper doesn't fit in, you can make sure that your calibration is perfect and doesn't need recalibration. And you can now rule out the platform as a source of any misprint. Thanks for watching.